It's my great honor to be awarded the SOBENA Awards of Excellence. My presentation today is part of the progress of collaboration between our two universities, UFRJ and the China University of Petroleum. I will talk about the background of our research and the progress we got and the future work we are going to do. This is the traditional subsea production system. How can we increase the safety and reliability of the system, and how can we reduce the costs of the system? The installation of all those facilities costs a lot of money, and the installation causes hazards and safety problems in engineering. The aim of our research is to develop some new concepts to reduce the costs and to increase the safety and reliability. So we get together 4 years ago to have a discussion about the possibility of the new concept to reduce the cost and increase the safety and reliability. And we established a joint research institute for deep sea technologies to fasten our collaboration between our two universities. This is the result of our discussion at that moment. We proposed 4 concepts: highly integrated of the facilities, spatial layout of the subsea production system, never blocked floor, and highly intelligence of the fields for the whole life cycle. We tried to develop a chamber fixed on top of the wellhead and big enough to install all the facilities of the production system. We tried to develop a very simplified manifold to be floated about 200 meters above the seabed to reduce the cost of the manifold and especially the cost of the installation. We tried to apply intelligent technologies to the facilities of the system and to the process of the oil and gas and the management of all the facilities. Is it possible to have the wax and hydrates to flow together with oil and gas, water and sands? We propose an idea: never blocked floor. I'll present the main progresses of these 4 concepts. This is the overall design of the chamber connected with BOP, transportation resource, and the wellhead. The challenge of the design of the chamber is the stability of the structure. One way is to develop a T-beam structure, and we proposed an equation for the design of the structures. We also developed a honeycomb composite sandwich structure of the shells, but we still have the difficulties in developing the theory of the buckling strength for the design of the structures. For the design of the chamber system, we have to solve the problems of the connection of the chamber with outside, the connection with the blowout preventer. The main point of difficulties is the sealing of the components of the connectors. The second connection is the connect of the chamber with the transportation or pipelines. Besides quick connecting, the connected resource has to have the ability of bearing the mooring forces from the manifold. For the connection between the subsea wellhead and Christmas tree, we have to develop technologies of quick connect and disconnect. The difficulty of this connection is the reliability of sealing structures of the connectors. The most difficult connection is between the central control system and the umbilical cables. The bundle connection has to be assured of the reliability of connection to the transport power energy, data transmission channels, hydraulic power channels, and necessary chemical agents. The chamber system is very large and heavy, so we use the suction piles to support the chamber system and to prevent the sinking of the system and to prevent the safety of the wellhead. It is also much easier and safer to install the chamber system. The overall design of the floating system is the large manifold to be floated above the seabed. And the difficulties of the system is the wrestle system we call flexible jumpers. It has to have the capacity of both transportation of oil and gas and the capacity of mooring lines. As all the processing facilities are integrated into the chambers, the manifold has the function only for the transportation of the resource and exploitation of the pipelines. This is the layout of the equipment and structures. This is the details of the parameters for the design of the manifold. As we just mentioned, the problem of the system is the design of the resource, which has to have the capacity of transportation of oil and gas and the capacity of mooring. The difficult problem is the severe slugging interaction with the resource system. We try to apply intelligent technologies to the subsea production system for the management of the whole system and also for the development of the facilities. We try to develop smart sensors for the monitoring and for the diagnosis and warning. We develop a set of intelligent monitoring systems to monitor the damage of the chambers during the service period and to develop technologies for subsea communication and subsea electric energy collection. To prevent the damage of the surface of the chamber, we try to develop self-adaptive and self-healing protective coatings. Besides, this coating has very excellent self-alarm function. By the intelligent monitoring from the sensors, we developed an intelligent control of the subsea production system. We developed a simulation system, and also we developed an intelligent comprehensive diagnosis method. This method and system can effectively solve the problem of false positives and false negatives, and the process can effectively distinguish. Never blocked flow is the new idea we proposed. We try to have the wax and hedges to flow together. How we can do it? The first is to reduce the resistance of the flow. And the second one is try to separate the oil and gas from the flow. And then we try to remove the wax and make the hedges in a condition of given sizes. Then to make it flow at very lower pressures and much lower temperatures, like 50 or 16 degrees. We try to develop some nanofilms to reduce the resistance of the flow on the pipelines. This is the experiment results of the contact angles of the coating and the oil. To prevent the damages of the flow, especially the sands on the pipelines, we developed other nanofilms to prevent the damages. This is also the testing results of the abrasion resistance. To remove the wax, we also develop some nanofilms. This is the experiment to indicate that the wax droplets on the surface of the coated materials can be easily removed, while the wax droplets on the surface of the uncoated material cannot be removed. To prevent the electrical heating or cycling of hot water, we try to use some materials to supply heat by phase changing. We try to use the microcapsule or microcapsule composites to have a new insulation layer. These pictures show the method of the nano-based phase change microcapsules. We can see the testing and simulation results. It's not easy to get the temperature distribution of the insulation pipelines. We developed an equation to calculate the heat transfer of the pipelines during the phase changing process. The theory of this problem was published in the International Journal of Heat and Mass Transfer. I just proposed the main progresses of our collaboration in the past 4 years. For the future work, we also have some considerations. Although we obtained some results of the new concepts, but we still have a lot of difficulties in applying them to engineering, although we have succeeded in the application of some of the concepts to the engineering, like the application of the installation of the large manifold to the South China Sea and others. And the Chinese industry of oil and gas are also taking part in our research, and they are considering the application of all the concepts. "20 years ago, Beijing, Levy, and Sphere initiated the collaboration between China and Brazil. 2008, the first 2 students came to Rio for their research for their PhD. And up to now, we have about 20 students stay here, and over 10 have obtained their degree and come back to China. At this moment, I'm very grateful to professors of all others, like Murilu, Teodoro, and Sujie, and all of them. It is their efforts to make me succeed, and I look forward the more successful collaboration between us, between our countries, and between our 2 universities. Thank you all for your attention, and thank SOBENA for awarding me. It is the award not only to me, it is the award to the collaboration of our 2 countries.